Hello, second hour. This is the beginning of Module 1, which, if you remember us talking about, is the unit we will be discussing and working on for the next several weeks. Our very first topic is factors and area, so that's where we're starting at today. We are just working on the introduction to the lesson. If you are taking notes along with me, I've titled an entire page. If I were you, I would just write it across the top. Again, factors and area. This is the beginning of topic 1. Okay, so the first lesson in topic 1 is titled Taking Apart Numbers and Shapes. Okay, AKA stands for, also known as, writing equivalent expressions using the distributive property. Okay, if you still don't understand what that means, equivalent means equal. Okay, so that's what I have written up here is equal. So we're writing equal. And expressions we've already covered. Expressions are things that have numbers, an add, a subtract, a multiply, a divide, and no equal sign. So we're going to be writing equal expressions using the distributive property. Now, the distributive property I put down here, we will get to this later. Okay, we're not going to cover that today. We're just going to work on a little bit of background knowledge. Okay, to begin, we are going to review over the area of rectangles and how we find them. I would stop in class right now and ask you, how do you find the area of a rectangle? And somebody would tell me, or I would show you the poster on the wall where it says A equals, A stands for area, and then it says length times width. Okay, so area is equal to the length times the width of the rectangle. Okay, and if anyone is confused over what area really is, area is the way we would find how much, like, wrapping paper we would need to cover, say, this square right here, or how much paper we would need to cover our bulletin board. Okay, so in the rectangle here I have brought with me these little cubes, okay, just to set inside for visual aid. Okay, so I'm going to say that my rectangle over here is 3 units. I'm using the word units in place of inches or centimeters because I really don't know how long these are. And over here, this side is 4 units long. And we know, since it's a rectangle, this is also 4 and this would also be 3. So to find the area of, I'm going to scooch this up some, of this rectangle, I'm going to come over to the side to show my work. Area equals, and this is where I would ask you guys to say it, you would say length times width. Okay, now it doesn't matter which one we use as length and width, because either way, when we multiply our two numbers, we're going to get the same answer. Okay, so I'm going to say the length is 4 and the width is 3. So the length is 4 and the width is 3. So I'm going to come down here and put some notes, that way I can remember. I'm going to put length and width. Doesn't really matter. You don't have to do that part. Okay? And then to get my answer, I'm moving my camera around so it stays a little clearer, I'm going to figure out what 4 times 3 is, or what 3 times 4 is. And it comes out to be 12. And whenever we are labeling area, we put our unit squared because we are talking about a two-dimensional object, so we put a 2 on it. Okay, if we were talking about 3 dimensions, so something that was a 3-dimensional figure, we would put a 3 right here. But that rectangle right there isn't 3 dimensions. It's laying flat on a piece of paper. Okay, so let's come back to our little model here and discuss 12 and how we came up with 12. So we had 3 groups of 4. Okay, so 3 groups of 4. So here's a group, here's a group, and here's a group. I intentionally staggered the colors. Okay, so if we had 3 groups of 4, we could go through and count these individually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we also get the same answer. Okay, if you don't know 4 times 3, that's fine to do until you get to problems that are way too big to sit and take the time to count. That's why we need to remember the formula and to multiply. Okay, so that was the little bit of the review we're going to cover on how to find area of rectangles. We aren't going to be finding the area of rectangles directly, but we will have to use it in this lesson. Okay, the next thing we are going to have to use in this lesson, we're not going to be working specifically like this, but we're going to have to understand the idea of decomposing or taking apart a number. And by taking apart, I don't mean separate the 5 from the 0. Okay, I mean coming up with different ways to get 50. Okay, so I have labeled my box plus, minus, multiply, divide. And I'm going to say to myself, okay, how can I get 50 with using addition? Well, I can do 25 plus 25. I can do 10 plus 40. I could do 10 plus 10 plus 10 plus 10 plus 10. Okay, I could also do 40 plus 10. Okay, when you flip-flop the order in addition, flip-flopping the order of your addition problem is called the, and I would pause to ask if anybody knew, and it is called the commutative property. So I'm going to write that to the side. Commutative property. I'll move my hand in just a second so you guys can see. So commutative property. Okay, I'm not going to take the time to fill up all of those. Okay, just because this is just examples. I'm going to move and ask myself, okay, how can I come up with 50 using subtraction? I automatically, when I think 50, I think of 2 quarters. Okay, so if I'm thinking about money, 3 quarters, which is 75, minus a quarter would get me 50. Okay, I could get 50 by doing 100 minus 50. I could do 60 minus 10. Let's do one more. How about 90 minus 40? All of those are options to get me to 50. So these are all expressions because expressions do not have equal signs. Okay, then I'm going to move on to multiplication. What can I multiply together to get to 50? First off, I think 2 times 25, or I could say 25 times 2, because when you flip-flop the order, that's called the commutative property. You still have to get the same answer, but if you can flip-flop and get the same answer, it's called the commutative property. I could do 10 times 5. I could do, let's see, it's another way for us to get 50 that's different. Well, how about the easiest way? 1 times 50. You can always use 1. Now this, using a 1 isn't going to be really all that beneficial in our lesson, but this isn't the lesson. This is just to get you guys thinking. If we move on to dividing, how can I place 2 numbers in an expression using division that will get me an answer of 50. Okay, so when I'm thinking 50s, if I count by 50s, I go 50, 100, 150, 200, 250. Okay, so 250 is 5. So if I do 250 divided by 5, it's going to equal 50. Okay, if I do 100 divided by 2, I will also get 50. If I do 300 divided by 6, I'll get 50. Okay, if I do 150 divided by 3, I will also get 50. Okay, so doing this will probably take you a little while because I know you guys are not completely fluent in your multiplication. Okay, so this may take you a little bit of time to come up with. So that is what your assignment is going to be. Okay, your assignment is going to be breaking apart the number 24. So how can we get 24 with addition, subtraction, multiplication, and division? You're going to work it the same exact way I did with the 50. Okay, you're just doing 24. Okay, I will also give you a couple of these problems just as refresher work to get us ready for the lesson. Okay, that's going to be in a Google form and it will be attached below. So after watching this and you understand it, if not, back up and rewatch it, and then go and work out the problems in Google Form or Google Doc, however I decide to do it. Okay, bye guys.